Yeah, hello everybody. Welcome to the last session for today. Before we really start, please show me who attended the previous session from Dimitro and David. Okay, very good. Because you will see that these two sessions really relate to each other. So there might be a slight overlap, but then my focus will be more in the SQL Server world and not the service tier world. Okay, before we start, I'd like to briefly introduce myself. My name is Jörg Stryk. I'm in the Navision world for quite some time. In the meantime, I have a 100% focus on NAV SQL performance issues and everything that is in touch with this. So there is a chance that our paths have crossed in the past already. Okay, so performance it shall be, performance it will be. Generally, when we talk about performance issues, we always have three major areas. It actually starts with the platform, the hardware, the infrastructure that is to carry all the system, the SQL Server, the database, and the application. So infrastructure, platform, hardware, this is the most important thing. The second area, that is about query strategy, indexing, and stuff like this. This is how Navision communicates with the SQL Server. David referred to this at the end of his session. Yeah, that is all about indexing, expensive queries, missing indexes, and all that stuff. And the third big area is all about blocking and deadlocking. This is a little bit of application technology, but a lot of workflow and business process design. So, about these previous sessions, or the other two topics, there have been some sessions in the previous TechDays events. So have in mind that these session recordings are still available on Mibuso for download. So if you would like to follow up in more detail about these other areas. Today I would like to talk about platform, hardware, which is actually the most important part of everything. The platform, the hardware, is the thing that is the fundament on which the SQL Server is installed. SQL Server needs to be configured and so on. And then the SQL Server is servicing the databases. And on top of this, of the databases, there's the application code, our dear NAV, using all this system underneath. What I never dare to put on the slide is what is missing here. On top of this pyramid, this is our dear user, sitting there and crapping down on this. There's the mean saying that half of the problems are sitting in front of the screen, but this is hardly something we can do anything about. Yeah, so hardware platform is the important part, and it's also important to have in mind that if we have hardware problems, these are the ones that are the easiest ones to be fixed. So when we look into at the time we need to spend to fix any issues, hardware issues are resolved as fast as possible. For example, if we find out that our dear SQL Server is lacking memory, we just don't have enough memory for memory problem. So if you have a virtual server, in the easiest case, it's just moving a slider from 16 gigabyte to 32 gigabyte, and the problem is resolved. Nowadays, you don't even have to restart the machine. Problem gone. If you find out that whole business processes are designed in the wrong way, that you have to cut open any code units, disembowel them and recreate them from the scratch. So when we are on top of this pyramid, this takes way longer to fix these kind of problems. So you might ask, if the platform is so important, why is this session coming so late? Because you asked for it. Nobody ever would volunteer to present a session about hardware, because this is a game you can only lose. Talking about hardware is talking about technology, and while talking about this, I present outdated information. And to design the perfect platform is really a challenge, and to give any guidance here is an even greater challenge. If you remember Navision 5 Service Pack 1, there was an attempt from Microsoft that provided a hardware sizing guide. This was kind of table sheet where you can say, you could see the number of users, the database size, and then you got recommendations of how many CPU, how much RAM, what disk system, and what SQL Server edition you should use. Yeah, by the end of the day, Microsoft was whiplashed for this proposal because those of you who really obeyed this hardware sizing guide really regretted it because it doesn't work, it cannot work. The problem with hardware sizing is that there are way too many dependencies. It really depends on the individual installation. So there's many questions to ask. If you have a bare metal installation, if you have a virtual environment, do you have private clouds? How do the clients interact? So do you have LAN connections, WAN connections, Citrix connections, and everything? Do you use SAN solutions and stuff like this? So there's a lot of dependencies that need to be clarified. So it's tricky. Nonetheless, I'll give it a try. So during this session, I would try to give some guidance of how hardware components could be sized, give you some formulas you can use so that you are enabled to create a robust and scalable system. Always having in mind that whatever I say needs to be put into your individual context. Okay. Just a second. Okay. The first thing I'd like to demonstrate is how to monitor performance. Those of you attending the previous session have already seen Windows Performance Monitor is the tool to find out how hardware is working. For those who did not attend, I'd like to show this briefly. Whenever you install something on a Windows computer, this component or this software can install lots of indicators that provide information about health status or whatever information. So this information is there already installed by the applications. The Windows Performance Monitor is just a tool that is able to collect this information, to save it, to record it, and to visualize the data. So once you have started this perf one, and my apologies that this is a German installation as every year, so it's an easy tool. You can open this, and then with a simple add, so you can collect an assembly of indicators from the local computer. That could also be a remote computer, whatever. And then you see that all kinds of components that are installed in the system provide this kind of information, from the .NET framework, the operating system, down to the SQL Server instances. And as what you have seen in the previous session, also the Navision service tiers provide information here. So you can pick the indicators of your choice, whatever this should be. Oh, not this AXP. So something like physical disk. And as you see, there's a lot of indicators. And then every indicator is split into multiple instances, so there are a zillion of measurement points you can take in. So the clicking around is easy, but what you have at the end here is a non-persistent setup. So whenever you close Performance Monitor, all your assembly is just gone. So that's why it's more feasible to use so-called counter logs. This is a persistent setup of indicators. You can create this in the same way. But the big advantage is if you have created such an assembly, you can export this as a template and reuse it. So it's portable. So you can create your assembly at home and then take it to your customers or wherever you like. So I have prepared such an assembly. And all that I use and what I show is already there for download on my blog. So you get these kind of performance monitor templates. There's also a template for monitoring the NAV server, SQL Server, and everything. Okay, so this is a template I have prepared for this environment. I can tell where to save it, maybe the security context in which it should run. And then I just have a predefined assembly of counters that I would like to monitor. So this is lots of indicators throughout the whole system, so from memory, CPU, network, disks, and SQL Server. So on everything. What I recommend to do is, when you have this kind of setup, always save into a file. It is technically possible to also save into a table, but table data is hardly portable. So if you save it to a file, you can always do the tracing, for example, on customer side, and then pick the data up and do the investigation in your home office. The collection I have here is defined to sample in an interval of 1 second. This is the highest one possible. And this is really necessary to have such a high frequency to really get a sharp picture. Downside is this assembly or this collection roughly collects about 100 megabytes per hour. So this is nothing you should run during all the day. What I recommend is to do this kind of performance monitoring during different times in the day. So maybe 2 hours in the beginning, in the morning when the business starts up, 2 hours in the peak load, 2 hours at nighttime, whatever is suitable. So I have multiple snapshots, but with a very high frequency. The reason is that most operations that happen in SQL Server are handled within microseconds, or at least milliseconds. So even an interval of 1 second is pretty long, and the longer the interval, the more information we miss. Yeah, so once this is set up, you can start this manually, and this is the huge advantage. You can also schedule this, tell when to start, when to stop, and so on. So with this, you have an easy way to monitor how the platform is behaving. And in the following, I will highlight some of the indicators and tell you what you can learn from these indicators and how to investigate this information to learn about hardware problems, and how to resolve them probably. So this is an onboard feature provided, which is available in any Windows PC. Any computer has this Windows Performance Monitor. When it's about SQL Server, there's also a little thingy where we can have a little insight into the infrastructure. Here I'm presenting a script created by Paul Rental. This is an SQL guy. He writes a great blog, SQLskills.com, so I highly recommend this. And this little script here is reading out the so-called weight statistics of SQL Server. So. Okay. Yeah, SQL Server is waiting always for something. So nothing works infinitely fast. The question is what it is waiting for and how long does it take? Yes, and here there are indicators that are related to platform, like I/O. That's something to do with a disk, like page I/O-lages. There are indicators that refer to the network. And there are other indicators that refer maybe to the application, like blocking issues or something like this. So that means also from an SQL Server perspective, we have a chance to get a clue about maybe hardware issues. Okay. So when discussing how to size a bare metal installation, the reason why you are here is that we're not talking about Azure and cloud and everything, about the fluffy stuff. Here we talk about heavy metal. Okay. Yeah, good one. Okay, so the first challenge to face when you set up an SQL Server platform is to pick the right edition of the server systems. So you need to be aware of the limitations that a Windows server has and an SQL server has. There are limitations in respect of using the number of CPUs, of using memories. And as you can see, these limitations change from version to version. And this could be sometimes really, really annoying, because if you see in SQL Server 2008, R1 and R2, the SQL Server limitation is higher than the operating limitation. Yeah, so if you think you go for standard leak and have a Windows standard system and put on top a SQL standard system, your limit is not 64 gigabyte, it is 32 gigabytes because Windows overrules. Pity for those who started with SQL Server 2008 release 1, they could have maybe an installation with 96 gigabytes of memory. Then they think they're just upgrading to the newest version R2, and there's a limit of 64. Yeah, this sucks big time then. So you need to be aware of these limitations, because later on when we calculate the number of CPUs and the RAM we need, this might spoil the thing. What I personally recommend is, whenever it's affordable, always go for enterprise on the Windows layer, because then you are unlimited, and usually Windows Server, the pricing is not that high. The price difference between standard and enterprise is not that dramatic. With SQL Server, this might be a bitter pill to swallow, because the price difference between standard and enterprise is dramatic. So the cost for an enterprise edition nowadays is a decent German car up to a small house, just for the licenses. Okay, so the first component I'd like to talk about is the CPU. So just generally speaking, a CPU, talking about a physical CPU, also talking about a socket. This is just the chip. That's what we call the socket. Every socket, every physical CPU nowadays is split into multiple cores. And each core could create multiple threads. So nowadays we have always to distinguish between a physical processor, that is, we're talking about the sockets, or talking about the logical processors, that is the threads. And here also it is important to know that licensing model has changed in SQL Server. In the old days, if you had to buy SQL Server on a processor license, in the old days means up to SQL Server 2008 R2, we could license on a socket base. Nowadays, we are paying for the threads. Yeah, so this is way more expensive. Yeah, what is the CPU about? CPU is the thing that is actually doing all the work. In terms of NAV and SQL Server, the NAV server is asking the questions, and the CPU is creating these questions, landing into the SQL Server. SQL Server is the thingy that needs to answer these questions to process the queries from SQL Server. So the challenge for the CPU is to process the queries. So it depends on the number of queries that are fired from the SQL Server. So when we want to have a rough formula how to size the number of CPUs, nowadays you can say approximately one logical CPU, one core is fair enough for 20 to 25 users. So if you're going to run NAV with about 100 concurrent users, yeah, so you need something in a range of 4 to 6 CPU maybe. In the old days, the rule of thumb was one socket per 100 users. Yeah, but nowadays we cannot talk about a socket anymore. We need to think threads. So that's an easy formula. What we want to achieve with this, by the end of the day, the CPU load, when we monitor it with Windows Performance Monitor, should not exceed this range between 15 and 25%. As a rule of thumb, you can say room temperature. Room temperature load, German room temperature, or European centigrade. This is a fair workload for a CPU. In some older Microsoft documentation, you might see that they say, okay, a CPU is dead when you start to exceed the threshold of 80% or something like this. And I say, if your average CPU load is at 80%, you're stone dead and didn't hear the shot. So, and I'll show you later on why this is the case. So, in all these slides, they always built the same way. On top, I have these Windows performance indicators that can give you a clue about upcoming problems. And then some brief sizing rules, and also some stuff you need to be aware regarding the configuration. So for the CPU, one thing that is always forgotten on any SQL server, you have to remember that nowadays all the Windows servers or all Windows operating systems are using power plants. And by default, they are switched to balanced. And balanced means that Windows is reducing the CPU speed to save energy. And of course, this is absolute nonsense. Yeah, an SQL server should not save energy, it should perform. So this is the first thing to do, really to switch the operating system to high performance. There's also a BIOS setting, which you have to regard. So if the BIOS setting is also switched to power mode, power saving mode, this needs to be disabled. Yeah, else the system just will not use all the system resources, so slowing down. Okay. So, within SQL Server, there's one setting that is highly discussed. There's only one single setting that has to do with the CPU configuration for now. And this is in the SQL Server instance properties. There's a setting that is called maximum degree of parallelism. And this is a mean thing you have to be aware of. In previous sessions, we were talking about expensive queries. So that is queries that put a lot of stress on the RAM, on the CPU, and anything, with missing indexes and stuff like this. If such a query happens, then SQL Server will split this query into multiple CPU threads. And this setting here tells SQL Server how many threads it could create. 0 means use all the CPUs that are available. And that bears the risk that if you have one of these expensive queries, that one query splits up into 8 threads, in my case, and overloading all the CPU. So one single user, one single query could create a global problem. And for that reason, it's always necessary, regardless if it's an NAV SQL Server or anything else, you need to reduce this. And the best practice is to reduce this to the half number of CPU, or to the amount of CPU you have in one NUMA node. At my machine, I have 8 CPUs, so I set it to 4. Because that means that queries still can benefit from a decent amount of parallelism. They can create 4 threads, but it doesn't happen that one query is overloading all the CPU. So this is, let's say, a common best practice. For Navision, in many cases, that's not even enough. Even we have relational commands. We have these page queries with the smart queries, how flow fields are queried and stuff like this. These are queries that indeed can benefit from this kind of parallelism. But most of the NAV queries are plainly stupid simple. Yeah, so if you ever have looked into a Navision query, a select command, filter, where, order by, there is nothing to be parallelized. And with Navision, something weird happens. It's called parallel index scans. And to avoid these parallel index scans, you still find it in some configuration guides from Microsoft that for NAV best practice is to switch it down to 1. 1 means one query is one thread. So we suppress all kinds of parallelization, which is fair enough for Navision, but of course that's stupid for anything that is intelligent in this system. So all the system maintenance, backups, index maintenance, integrity checks, all of these kind of operations will be degraded because that's operations designed to run on multiple threads, and now you suppress this. So yeah, what's good for an NAV is not necessarily good for the rest of the world. So I suggest to do this. Start with a half number of CPUs. And then in these weight statistics, there's a counter that's called the CX packet weights. This tells if you have any problems with parallelization, if too much time is spent for this multi-threading. And if this counter is in the top ranks, so with this script, if it's on the rank, let's say in the top 5, then you need to decrease the CX packet weights further down. So then you should do it step by step. So the first step is half number of CPUs, in my case 4. The next step would be 2, and the worst case is actually 1. Yeah, unfortunately, especially in the old NAV versions before 2013, you often end up in having max stop 1. There's one indicator that is most important if you are running virtual environments. On a virtual platform, you have a virtual host that has a finite amount of hardware resources, a number of CPUs, a number of memory, and so on. And out of from this virtual host, you are able to create your virtual servers. So you assign a decent amount of RAM and CPU to the server and so on. And hell will break loose if you do some over-provisioning, or if you overbook the virtual host. An example, you have a virtual host, a physical machine with 8 CPUs. So you only have 8 physical CPUs, or logical CPUs, sorry. So that means you can create 2 virtual servers, each of 4 CPUs. Or you can create 4 servers, each 2 CPUs. Yeah? You always end up in a total of 8 CPUs. Beware if you create 4 servers, each 8 CPUs. Technically, that's possible. But then you kind of overbooked the virtual host. This is like Lufthansa is selling more tickets than they have seats. Yeah, somebody has to wait in this case. And unlike Lufthansa, SQL Server does not give you a €100 voucher if you take the next flight. So if that happens, then the SQL Server machines will run berserk. And the indicator is as follows. You will see that the percent processor time, the CPU load, is in a normal range, is in a range of, let's say, 15%, all okay. But then you will see that this privilege time is increasing. The privilege time, that's the time a Windows system spends in kernel mode. This is time spent for managing internal operations, like managing devices, like disks, network, and so on. And this is also like the negotiation between Windows and the virtual layer. So that means if this privilege time is increasing, more time is spent for this handling internal stuff than for the real processing. And this happens if you have an over-provisioned, overbooked virtual system. This is like this, that there's an SQL server coming to the Windows and says, hey, guy, I need to process something. Give me a new CPU. Yeah, and then the SQL server has to say, or the Windows actually says, sorry, guys, I have to call my boss. Yeah, and is calling the virtual host. And the virtual host says, okay, hang on, be patient. I have to look up a spare CPU for your processing. Yeah, and while Windows is hanging on the phone and waiting, this is increasing the privilege time. And the next level of this problem is that there's more SQL stuff coming. Another one coming from you. Hey, I also have something to process. This is the processor queue length that is then filling up. This is the channel into the CPU. So the CPU just cannot process. It cannot forward the requests to the virtual host. So the threads actually are just stuck up in this queue. And by the end of the day, it all gets so slow. Yeah, the problem is often that if you have these virtual hosts and someone who administrates this and manages this, they tell you, oh, everything is okay. The CPU load is at 15%. There's a lot of things to take. It can take way more workload. Yes, from a virtual host perspective, that is the case. But from an SQL Server perspective, it all just queues up and the system cannot process. So beware of this overbooking of virtual environments, because sooner or later this will hurt. Okay, so that means CPU actually is an easy thing to size and to configure. So this is just an example taken based on this performance monitor data. This is an average CPU load of about 12% or something like this. So all in this room temperature range, where I say this is okay. 80%, that is the old Microsoft threshold. But this is the average among all the total CPUs. I think that in this box it was 8 or 10 CPUs. And now if we look into this on a core level, then we see that every single core frequently hits this red area and is fired up to 100%. And this is exactly what we want to have. Because when we look into our Navision background noise, what happens in Navision? Yeah, there's all this GUI interaction, opening a page here, opening a form here, and stuff like this. That doesn't fire a lot of queries. Yeah, if you open a page that's a little bit of item record, a little bit of flow feed here, let it be a dozen of queries. So that's not really stressing SQL Server. So the background noise is really moderate in NAV. But then we have these special operations like creating documents, posting documents, running reports and stuff like this. And even nowadays, we have always this loopy code, yeah, this a loop within a loop. Navision always has the same structure: set key, set filter, repeat until, and repeat until. And this means when these kind of heavy processes are started up, then a lot of queries are fired to the SQL server. And this is what the CPU is needed for, to handle these peak loads. Yeah? And these are the peaks we see. And these peaks that should happen just a split second, just fire up to 100% and go down. This is what we want to see. Now imagine we're living in the old Microsoft thresholds. If that curve is at 80%, yeah, then you don't want to see that one. This machine is stone dead, bones bleaching in the desert sun. Okay. According to this, it's always important to see also the number of users creating the workload. Yeah, is it one user, one application server killing the system, or is it in this case 100+ users? And the number of queries these users are firing. And as you can see, that can be a lot. So that means there is batch requests per second. That means about 5,000 queries per second that are fired from an NAV to an SQL server. And this is something to take. Yeah, that's where we need our dear CPU. Our dear memory. In SQL Server, it is all about memory. This is the most important component in SQL Server because SQL Server is managing all the data exclusively in RAM. Those of you knowing still the old native C-side server. C-side server is just a data pump from disk to client. It's just a pump station, not SQL Server. SQL Server is only loading the data from the disk if necessary, and then it tries to keep all the data in the memory as long as possible. SQL Server ships data only from RAM. So if it's not there in the memory, then it has to fetch it from the disk, and then data remains there in the RAM. But RAM is not only needed for maintaining the data. RAM is also needed for maintaining logs, to maintain connections, to save the execution plans, and all this stuff. So memory is absolutely crucial. So the question now is, how big should my RAM be? And in this old hardware sizing guide, they were telling you it is based on the database size. Yeah, if you have a small database with 1 GB, so you could have an SQL server with 3 GB of RAM. Yeah, great, but bloody hell, we all start with a Kronos database of 500 MB. So we all start with an SQL server of 3 GB, and then, yeah, so that maybe it takes, or it's just fair enough for a week, for a month, and in a very short time, we will be in need of way more memory. Yes, so the size of the database has something to do with the RAM, but this could not be the criteria because our dear Navision is, well, I'd like to say a data cemetery. Yeah? Everyone goes in, no one ever gets out. This thing is doomed to grow forever. So, and we cannot have a RAM linearly growing with the database. Yeah, so what I can tell, or what I should say is, you never want to install an SQL server with less than 8 GB of memory. Even if it's a single place test installation or anything, anything else you will terribly regret. But I have a different approach. So why thinking about database size, number of users? So how should I estimate the data volume that is created in the system? Yeah, Microsoft is not shipping these crystal balls we all need to see what really happens on this system. So I have a different approach because memory doesn't cost a thing today. Hardware is cheap. So what is the difference of having a server with 16 GB or 64 GB? We're talking maybe about 1,000, 1,500 euros. What is that? That's piece of cake compared to the license cost for a Navision project. Yeah, so we have 150,000 euros license costs SQL Server Navision license, plus the development. And now we are arguing about 1,500 euros for memory. Why? So I suggest just look into the limitations of the SQL edition, of the Windows edition, and then put in as much as possible, as much as is affordable. Of course, all needs to be in a reasonable, healthy state. Yeah? It's not recommended to put in 2 TB just for fun or something like this. Yeah, but this is how I would think it. Because that way you can create a robust and scalable system. Yeah, you should erase the term from your vocabulary, oversized. There is no such a thing that, as oversizing. The term is scalable and forgiving. Yeah, and sooner or later this memory will be needed. Okay, to monitor the system, from a Windows perspective, most important is the available megabytes. A Windows server never ever must drop below 100 megabytes, else it will switch into panic mode. It will page out whatever is necessary. The CPU will run berserk, so the server is completely done. So never ever this indicator must drop below 100. A couple of 100 megabytes is always feasible. Let it be 500, half a gig, because then it's forgiving. Then you can open a Navision client on this server and do some work here, or whatever you need to do. So this is most important for Windows, independent if it's an SQL server, a service tier, or whatever machine. We can monitor the page file. Yeah, as you know, paging is bad. That applies also to any computer. And there's a Windows performance counter that just shows the page file usage. So that means that should be a flat line on the ground, not using page file anymore. In SQL Server, the most important indicator to tell if the system is healthy or not, this is the buffer cache hit ratio. As mentioned before, SQL Server always works like this. A client sends a query to the server. Then the server first looks up if the data is already in the cache memory. And only if it isn't there, then it has to pump it from the disk and then goes to the client. And this quality, this hit ratio, this is the buffer cache hit ratio shown here. And this should always be greater than 95%. That means it has at least 95% of all the data it needs for working in the memory. So it means it doesn't have to go to the disks that much, that often, and so it could process the data as fast as possible. If buffer cache hit ratio drops below this threshold, and that for a long time, then the reason is simply you have not enough RAM. There is no plan B, it's just lacking RAM. There are also indicators that show how long information remains in this cache. It should be greater than 5 minutes, so greater than 300 seconds. That is just the duration, how long an information remains in the RAM until it's overwritten and stuff like this. So the greater this is, the better it is. From a configuration perspective, there's also not that much to do. In SQL Server, in the instance properties, you have these memory settings. By default, there's no minimum, and the maximum is at 2 terabyte or something. So what you always should do is you should create a claim, a dedicated claim for the SQL Server and for the other world. So ideally, a SQL Server machine is always a dedicated box. So it's just the SQL Server on a Windows machine and no more. No other heavy services and stuff like this. Ideally, no service tiers, no web service, no nothing. In this case, a Windows operating system only needs about 2, in the worst case, 4 gigabytes of memory. So as a rule of thumb, the maximum server memory is always the amount of physical memory minus 2. In the case, if you have a machine with 16 gigabytes of memory, then it would be 1400. If you have a machine with a decent amount of memory, let's say 64 gigabyte, then you can be more generous and give SQL Server maybe 60 gigs and leaving 4 gigabytes for the Windows. Yeah, so that is necessary to have a dedicated claim. If you have other services up running, service tiers or whatever, then of course you have to subtract the requirements for these services as well. And this could be remarkable. This is currently discussed in the German user forum, where a Microsoft guy claimed that you should consider about 8 to 12 gigabytes for one service tier memory. I cannot believe it. So far I never have seen a service tier consuming more than 4 gigabytes, but this is a statement from a Microsoft guy and is currently discussed. Yeah. Okay, so ideally it's a dedicated server without any other heavy services. A minimum is not necessarily to set. Yeah, as a rule of thumb, you can say maybe a quarter or half of the maximum. That's what you want to pre-allocate as minimum. That means when the server starts up, it instantly allocates such a huge pool and doesn't have to allocate the memory dynamically. What is dangerous is something like this, minimum equal maximum. Because if that figure is too high and the SQL Server service starts too quick, kind of pulls out the memory share under other Windows services, and Windows may have problems in firing up other services and having a global operating system problem. So the minimum should not be more than quarter or half of the maximum. In this case, maybe 16% or something. Yeah, and that's all what we need to configure for the memory. In the SQL Server instance, what I also would highly recommend, when you do some changes here, I never push the OK button here. These are all things that can be done on the fly. They don't require a restart or anything and should take a split second. But if not, if for any weird reason the system hangs, there's no way back, management studios just will hang even for an hour or longer. And we have no idea what's going on. So what I always do, you always find in management studios these script buttons here. So when you do some changes, I go for a script. And here I'm canceling this. And here I have a SQL query, oops, almost, which is doing these changes. That way you have a documentation about the system changes you are doing. You learn a little bit of SQL, and if you execute this and anything weird happens, there's always the way back, always the cancel button. So this is what I highly recommend to do so. Yeah, normally it's a split second, but if not, yeah, just in case. Okay. There might be an exotic problem with the memory. If the server is too small regarding the memory, what we can see is that other services force Windows to page out memory. So SQL Server memory is paged out to provide this RAM to other services. If that happens, you get an error entry in the error log telling you something like a significant part of memory has been paged out and stuff like this. And always this paging takes time, and when this happens in SQL Server, it kind of freezes. Yeah, for a couple of seconds, there's no way back and forth. This is a very, very rare problem. I think I have seen it only twice in the past years. But just to avoid it, in the local group policies of Windows, again, my apologies for this being German, there is a right. In English, it's called log pages in memory. And the account that is used to run the SQL Server service should be assigned to this right. Because then SQL Server service has a kind of tight grip on its memory pages, and it could not be forced to page out the stuff that easily. Depending on the SQL Server edition, you may need to enable a trace flag 845. The enterprise editions instantly have a log pages support. The standard editions, they need this trace flag to engage really this log pages support. This is a nice to have. Yeah. So again, this actually is just disguising the real problem. The real problem is lacking RAM. But then again, it happens very, very seldom. Yeah, so when we look into the RAM, this is also taken from a customer system. This is a perfect buffer cache hit ratio. Yeah, I want to present to you, there's no fake scenario. There's really 2 hours monitoring of peak load in the system. Constantly 100%. They are not oversized, they are scalable. Now, in reality, in most systems, this looks like this. So the buffer cache hit ratio in average is in the range of 97%, 98%. And yes, of course, we have sometimes these deep drops. Yeah, that is the expensive queries. That is queries that use up a lot of reads where indexes are missing and stuff like this. This is when there's a kind of hit to the memory, and SQL Server has to fetch some more data. But this should be an exception and not the rule. This is how page life expectancy could look like. Yeah, again, this should be greater than 300 seconds. And here also we can see these expensive queries. Yeah, so the duration, how long this information remains, is at 5,000 seconds, a long time, 1.5 hours. And then there's a bad query flushing some memory. Okay, so be it. And then at the end, there's another expensive query flushing a lot of memory, but then we see it's recovering. Yeah, the life expectancy is increasing. This is normal behavior. This is what we want to have. Okay. So far, that has been easy. Now comes the challenge. Maybe I should stretch myself a little bit further. Okay, disk. The disk subsystem is the most important part of an SQL Server system, and it is the most expensive part of the system. Back to the roots. We need to be aware of RAIDs, RAID level systems, redundant arrays of disk. So just to bring it back into your mind. So we have the RAID 0, which is a striping, which means that among these spindles, the workload is distributed. We have a RAID 1, that is the mirroring. That means that information is just kind of copied from one disk to another one. So that means a RAID striping makes the system fast because the workload is split. That is the idea. Why do we need to split the workload? Because most common, we have these hard disks. And a hard disk is a mechanical thingy. Yeah, whenever you have looked into such a disk, there is a spindle turning and there's a read-write head moving up and down. So that's real mechanical work that happens here. And this has to obey some physical laws. So the speed of such a hard disk, this mechanical work, is limited by nature. So to have a fast I/O, to have a fast responding disk subsystem, it is possible to split the workload among several disks, to stripe, because then the mechanical work, the movement of the parts, is just half of the number in this case. Yeah, the more spindles we put in such a stripe, the more is the workload distributed, the less movement each spindle has to do. And this makes physical I/O, a physical interaction, fast. Mirroring is required for fault tolerance, to have the data safe. Because of course we have to make sure that if one disk gets down for whatever reason, yeah, it's physical thingy movement that can break down just for whatever reason, else the data would have been gone, so we need a kind of redundancy, and this is what mirroring is about, to copy the data to another disk, so if one disk goes down, the other one takes over. So the one thing makes it fast, the other one makes it safe. If you want to have it fast and safe, we need a combination that's RAID 10 or RAID 1.0. Yeah, this is the most common RAID levels we have in the SQL world. And later on, we show you the hardware or the database components that have different requirements in speed and fault tolerance, maybe. What always is around, like a ghost, and you never can really kill it. This is bloody RAID 5. This is most misunderstood RAID level you can find. The problem with a RAID 10 is that there's a lot of overhead of disks. Yet always the half number of disks is just there to take over just in case. Yeah, so they don't do actually kind of work. They don't really store any data. They're just there, but you have to pay for it. RAID 5 is cheaper because you don't have this redundancy. There's no data mirrored. So RAID 5 works that the data is striped among multiple disks, and then there's one disk for a parity sum. So the parity is just a kind of control sum to check if everything is okay. Yeah, reading from a RAID 5 is as fast as reading from a RAID 10. But the writing to a RAID 5 is hell, because the creation of this parity takes forever. So a RAID 5 level is an absolute no-go for any physical drives for databases. So never ever, if you have a physical array, a physical RAID array, never ever put a database component on a RAID 5. Yeah, that might be fair enough for backups or stuff like this, but never ever database or transaction or something like this. Yeah, so again, I have to highlight physical RAID volumes, because the story is very different if you're using SAN technology. Yeah, because I often have the discussion, yeah, then the customers are buying a huge SAN, and then the SAN guys say, okay, we need to configure it as a RAID 5. And then my customers say, no, Jörg said never ever do a RAID 5 and stuff. Yeah, but SAN is a different thingy. So SAN technology, this is also something that is really coming up. In the old days, we had the structure that every server had its own storage system. They had all these their own drives and everything. But this is a challenge regarding administration. Yeah, you have all these little islands, and you have to maintain all these little islands, providing disk and stuff like this. So most companies nowadays try to centralize their storage. Yeah, there's more data to store. It's not just SQL Server. They have Exchange data. They have a file server, maybe a SharePoint, or whatsoever. Yeah, and instead of maintaining all these small boxes somewhere around, many companies just try to have it on one huge box. And the deal is storage area networks. A storage area network is an array, a RAID array of many spindles. And indeed, these arrays have to be configured as a RAID 5 or 6 or something with double parity. The reason is simple. A real SAN, imagine they have 40 disks, and if that was configured in a RAID 10, that means half number of the disks have to be just wasted for fault tolerance, just for the mirroring. That would be insane, yeah? What kind of capacity you just waste for nothing. So SANs are not doing this. In a SAN, usually they use a double parity system, so they have even 2 disks for the parity figures, so redundancy for the parity. And there's so-called hot spare disks. That's just disks that take over in case any other disk gets down and goes corrupt. So this is a physical aggregate or target, depending on the manufacturer. And out of this physical target, there's so-called loons. The logical volumes are created. A loon is just a logical volume. And these loons, they are assigned to the using systems like SQL Server, Exchange, or whatever. The loons have the big advantage that they can be managed on the fly and very flexible. So you can increase the size on the fly. Nowadays, you don't even have to restart the machines or something like this, which is not possible with real physical RAID volumes. So why does RAID 5 work with a SAN? I just said never ever use stupid bloody RAID 5. Because between the loon, so the loon is the drive, how it is shown to the SQL server, for example. Between the loon and the disks, there's the controller. Let it be a fiber channel controller, iSCSI controller, or SAN header call, whatever you name it. And this controller also usually has a huge cache. And this is what is the very difference to any other physical RAID volumes. A normal disk controller has a cache measured in megabytes. Let it be 500 megabytes, 2,000 megabytes, hooray. This thingy here starts in a range of 8 gigabytes, 16 gigabytes and up. So that means virtually, when you have a real SAN solution, the SQL server is talking to a RAM disk. So it just puts data into this RAM disk of the fiber channel of the controller, and the controller instantly commits. If there's any I/O, the controller commits as soon as it is in its cache. So the SANs have a response time of about 2 milliseconds or something. Yeah, it's like RAM disk speed. The physical write to the disk happens asynchronously. Yeah, and of course this physical write sucks. It takes a long time because of the parity and stuff like this. But who cares? SQL Server is out of that game here. So this is the very difference, and this is the huge advantage when using SAN technology. Yeah, when it's about these disks, also frequently asked question is, what kind of disk should we use? The most common stuff is hard disk, yeah, these mechanical components. And again, these mechanical components have physical limits. Nowadays, the technology is solid-state disk. A solid-state disk is based on a flash memory technology that is like a USB stick on steroids. So there is no mechanical part, and this is why the response times are way, way, way quicker than with any hard disk. So you can say at least 10 times quicker than any possible hard disk. So the big advantage of solid states is that they can perform way more I/O operations per second. On the other hand, they are very, very expensive. As a rule of thumb, you can say that the price per gigabyte storage is 10 times more expensive on a solid state than on a hard disk. But the price per IOPS is 10 times cheaper on a solid state. So never ever use a solid state just for the mere storage of data, so for backups or whatever, or as a file server. So the real strength of solid states is the I/O, the pushing the data around, in and out. This is what solid states are made for. Yeah, I found this picture on the internet, also comparing these two thingies. Has a lot of advantages. So solid states really, really rock, but they are expensive. Yeah, so it's a matter of budget. With solid states, also you have to be aware that a solid state, this flash memory technology, a solid state can expire. These flash cells, they have a limited amount of write cycles. Let it be 100,000 in the old days. I think it's closing into 1 million nowadays. But at one point, these flash cells are simply expired. They are done. That's called the solid state blackout, SSD blackout. So the cheap stuff you have in your notebooks, at one day you just try to push to fire up your notebook, and it just doesn't fire up. It just won't start Windows. Farewell, there's no plan B, everything is gone. Yeah, that's when you buy cheap. Of course, this never ever must happen in a database server. Yeah, the SSD blackout is something we don't want to have in any database server. So there are some tweaks you find in the internet. In the internet, you find something like this: create a RAID 1. Yeah, you have with 2 solid states. You have a solid state there, and there's another one. Both start to work, so the data is mirrored. So after a couple of months, you remove the mirror disk and replace it by a new one. So the mirror is a few months younger than the old one. So at one day, the oldest disk expire, blackout, but there's still the mirror taken over, which is a few months younger. So you have a couple of months' time to replace the expired disk. So you always have to shift around. That sucks big time. Yeah, okay, it is a plan B, but who wants to fill with a disk subsystem every few weeks? No. So nowadays, solid state disks, they have reserve cells and they have mechanisms to alert, to notify if they start to use the reserves. But then we have to get used to a very different price tag. The last time I was looking up on a manufacturer page, there was a 400 gigabyte solid state with all these high-end features and everything. 400 gigabyte SSD, 6,800 euros. And you can buy a lot of hard disks for that. Yeah, so it's always technology versus budget. Yeah. And again, there are SAN solutions that can mix the cheap disk and the solid state. The thing that's called auto-tiering. The SAN can decide, okay, this is data that's heavily used, I put it on the solid state. There's data I don't use that much, I put it on the hard disk, and automatically can manage it. There's all pros and cons. Again, it really depends. The limit of a solid state is the bus. The bus, how it is connected, that's SAS or SATA. And this bus has a limit of a throughput capacity of 300 megabytes per second, roughly. And the next level of solid states is solid states that are connected by the PCI Express bus. Because the PCIe bus has a throughput of 1,000 to 1,500 megabytes per second. The most known manufacturer for this is Fusion IO. So most people talk about Fusion IO cards. That is solid states just plugged into the PCI Express bus. But again, more IOPS per second, faster response times, but such a price tag. Yeah, okay. So the disks are most important. And if you want to monitor the disk, in the internet you find zillions of indicators that give a clue about disk performance. But it all depends. For example, you might find an advice, check the average queue length. Average queue length should be less than two packets. But if it's a RAID 10 on a physical drive, you have to divide the number by the number of spindles you have in the RAID stripe, but not if you have a ZAN. Yeah, so what? So that's so many dependencies. The easiest way to find out if a disk is performing okay is just to use a simple stopwatch and just to measure how long does it take to write to it and to read from it. And with a hard disk, you would say today the story ends with 15 milliseconds. A 15 millisecond response time, that's fair enough for a hard disk. For a solid state, of course, that would be forever. Solid states respond technically less than 1 millisecond, so 5 milliseconds, that's absolute top limit. Also, some SQL indicators, that's accessing the disk subsystem from an SQL server perspective. These I/O ledgers, that's transporting data from disk to RAM. Same figures, yeah, always less than 15 milliseconds or less than 5 milliseconds. Write log is writing to the transaction log, I/O completion, other operations. That all relates to the disk. So, for the configuration, there's also something you should set in this local group policies. There's a right that is called perform volume maintenance tasks. And German Durchführen von Volumenwartungsaufgaben. Perform volume maintenance tasks, that sounds terrible. What is it? It's also known as instant file initialization. Normally, if you create a file on a computer, it has to be initialized internally. And this could take a while, depending on the file size. Now with our databases, we are handling gigabytes of files. And so it could take quite a decent time, or a long time, to initialize these things. Only if you are administrator, because then you have inherited this right already, or if you have get granted this right, if you have the right to perform volume maintenance task, this initialization happens instantly. So that means if you create a database, or you have to expand a database file, or if you have to create a backup on something like this, that takes a couple of seconds or maybe even minutes, because normally it has to be initialized. If you have this right, it just takes a split second. So the initialization happens instantly, and this could dramatically increase some of these file operations. So that's why the SQL service should have this right, speeding up backups and file operations, whatever. It's not a must-have, but a very nice to have. SQL Server is accessing the data on an extent level. Extents are 8 pages of 8 kilobyte. So one extent has the size of 64K. So that means it's a good idea to format the disk on 64K blocks, because that matches to the physical access of the SQL Server. Having in mind that ZANs may have different requirements. So always ask the manufacturer. Generally, you always should have different drives for these database components. So we need a separate drive for the OS. We need a separate volume for the database. Database file is accessed permanently random I/O. So that has very special requirements in IOPS per second. So there's a permanent in and out on the Navision database. The transaction log also needs a separate drive because it is accessed in a totally different pattern. We have no random access on the transaction log. Transaction log is accessed purely sequentially. And this is a totally different story in accessing the file, having different requirements for the spindles, and the read-write head, how it's moving around. The TempDB is used for sort operations in NAV. Normally, if you don't have any custom programming and so on. And again, you know your Navision, so it's used for sort operations. That can be 2 records, that can be 20 million records. So it's unpredictable what kind of pressure we have in a TempDB. So it is best practice to have a separate volume for the TempDB to separate the physical I/O. So this especially applies to the physical RAID volumes, especially if you have these hard disk RAIDs. From a RAID level perspective, the database file is a good candidate for a RAID 10. maybe the transaction log, and maybe in third priority the TempDB. Basically, this is all different if you have solid states, because with solid states we don't have this mechanical work. But still, let's say common best practice is to follow the same rules like with an old classic scenario, just to split it up into different components, but having in mind that you can break this rule. It really depends, and I can't give any advice how you really should do this, so if that, then do that. It really depends on the local structure and the number of disks and what kind of disk you have. Yeah, also if you have SAN. In a SAN, it's all a logical volume. By the end of the day, it all runs on the same controller, on the same disk. It's just a logical separation. And here it also makes sense to have multiple LUN for the different components, because then it's easier to troubleshoot. If you see, if you have all on the same LUN, which is technically possible, and you see some pressure coming on this, that the queues are filling up and the response time increasing, you never know if that is caused from the database, from the TempDB, or whatever. And if you have it on different LUNs, it's easier to see, okay, I have a pressure on this LUN, that's my database, or I have pressure on this other LUN, and that's the TempDB. So you can better identify where maybe problems are coming from. There are some special, later on, okay. Oh, really? Okay. Yeah, so this is how it looks like in performance monitor. Yeah, we see this baseline in a range of less than 50 milliseconds, and there's always some peaks. Yeah, and again, these peaks are pretty normal, nothing to worry about. Yeah, that's just exceptional, expensive queries that have to pump a lot of data from the disk. And we see this on the read and on the write level, it's the same thing. So never worry about these exceptions. What matters is the average within a representative period. So when we monitor for 2 hours or something, so we have to look what is the average in these 2 hours. That is telling a story. Yeah? There will always be exceptions, and again, this is normal. We have special requirements for the TempDB and database regarding the configuration. So I've already done this, so I don't start from the scratch. Normally, you only have one single TempDB file, and starting with 8 megabytes. This is ridiculous. So 8 megabyte TempDB is never sufficient, so what will happen, TempDB is recreated whenever you start the server. So usually it starts with 8 megabyte and then increasing. So what you will have is that there's a permanent auto growth. By default, it's 10%, increasing the TempDB data file. And this auto grow is something we need to avoid, because whenever you add a chunk to a file, it fragments. And the more it fragments, the slower it performs. So to avoid this auto growth, the idea is to set this single TempDB file to a decent, reasonable file size to handle, let's say, the maximum peak load that could happen. Yeah, it's just used temporary. It doesn't store any data. It's used, and then data is gone again. This is a little hard to predict. Yeah, what is the maximum size we need to handle here? And again, this size changes every day with every posting, tables getting larger, result sets getting larger, more pressure on the TempDB. Normally, the truth is somewhere in a range of 500 megabytes to maybe 2,000 megabytes per file. So, but still, when you have set this, autogrow should still be in place, just in case. Yeah? Never disable autogrow, because else the database will simply run into a halt and then it's done. What could happen is, now if you have only one single TempDB file, which is the default, if you have a huge pressure in this file, a lot of sort operations going on, then this file gets unavailable for other user processes. So you have TempDB contention, you have latencies on the TempDB. Yeah? Someone has to wait. But SQL Server could balance this if it has multiple data files. And the best practice is to have as many data files as you have CPU, but no more than 8 to 12. Nowadays you have to be careful. We have systems with 48 CPUs, so never create 48 files now. Yeah, and these all should be in the same layout, same growth and stuff like this. And then SQL Server could balance the load between the files, avoiding this TempDB contention and the latencies. Navision doesn't do any transactions in the TempDB, so it does not create or modify any data, so that we can totally forget about the transaction log here. That's only important if you have other applications up running on the server or your own custom programmings that are doing something on TempDB. For the Navision database, it also applies that we have to avoid autogrowth. So the data file size should be in a decent size. As a rule of thumb, you can say you need to have about 10% of free space. This free space is used for index maintenance operations. Defragmenting an index happens in that free space. If there is not enough free space, this index defragmentation will not expand the file. It just will not defragment the indexes. So the indexes remain fragmented. So 10% would be okay, and ideally, it is a human being that is monitoring this growth in the file size and so on. So some administrator should look at it and manually decide how to expand the database. Because maybe it's not just expanding the file, maybe you need to expand the loon, maybe you have to add another disk or something like this. Maybe it's wise to compress the database internally using SQL data compression or whatever. These are all decisions a human being should take and not the autopilot. Autopilot, the auto growth should just be in place to make sure that the database never ever runs into a hold. So it should be able to expand if necessary, of course. And then it should be a chunk that helps for a couple of days or maybe weeks. Yeah, again, this is a Kronos demo database. In reality, I suggest you have a growth of about a gigabyte at least, 1,000 to 5,000 megabytes. That is a decent chunk, and so that auto growth should not happen every 5 minutes again and again. That's also pointless. Yeah, for the transaction log, it depends on the backup frequency. Whenever you run a transaction log backup, information is truncated from the file. And what we want to achieve is a kind of cycling through the transaction log file. So whenever it hits the end, it starts from the beginning. So it depends on how often you back up the transaction log. I recommend to do that at least every hour. Rough rule of thumb is the transaction log should be about, or not bigger than about 20% of the net database size. Then again, if you have more frequent log backups, you can even decrease this size. And again, auto growth just in case. Okay, last but not least, our dear network. Network is easy, again, because hardly ever the SQL Server machine is causing a network issue or having a network issue. Usually the SQL Server machine is suffering from a network issue. Network problems are usually global things that you have in the whole company. Yeah, if the network sucks, you feel it on all kinds of places. It's not the SQL Server Navision getting slow, it's the internet getting slow, it's accessing the file server slow, everything sucks. Yeah, usually it's that you have a broken switch somewhere in the net or whatever, it's overpatched. So hardly ever SQL Server is the cause of a problem. Here it's just the symptom. To monitor from Windows performance perspective, there's a counter of the current bandwidth. I just put it here because I always or frequently come across this. People install a gigabit network card. Gigabit is standard nowadays. But it is worth to count the number of zeros in this current bandwidth, because sometimes you will just find out they have a gigabit card, but it's configured down to 100 megabits or something. Yeah, so they're throttling because of a stupid configuration, or they have a switch in between throttling the network I/O. That's an easy one to resolve. To see if the network is okay, that's the output queue length, the error packet queue. This should be empty. Yeah, that if that is always 0, that means there's no network I/O queued, and the server could communicate as it's supposed to do. From an SQL Server perspective, what you will see in the top ranks, if you have a classic Navision scenario, That is the OLEDB. That is the classic Navision clients communicating with the SQL server. And of course, that is the thing that happens most, yeah, the permanent in and out. And this should be less than 1 millisecond. Yeah, 1 millisecond, this is a normal network latency, what you have in the local area network. Yeah, if you do just a standard ping from one machine to another, it will tell you less than 1 millisecond. And this is also what you want to see here. With the service tiers, in a role-tailored scenario, what we will see, but we don't want to see, is the async network I/O. Async network I/O means that SQL Server ships data to a client, respective our Navision service tier, and just waits for this counterpart to commit, just to say, yes, I got it, yes, I understood and processed this. Normally, this also takes less than 1 millisecond, yeah, very fast. But our dear service tier seems to have a problem with certain queries. Yeah, also David mentioned this in his session before this one. The service tier has a problem in digesting large result sets. So if we have queries that retrieve or return tens of thousands of records, then we will see that the service tier goes down, regardless of the cache setting and if it's a dedicated machine or everything. That is just a problem. Yeah, this, especially if you have these kind of smart queries, this auto-calc flow field thingies when you open a page, when you have these huge queries, when all the flow fields are joined in and stuff like this. These are queries that really bring down the service tier. And this is shown by this async network I/O. So if that is in the top ranks and you see it's way longer than 1 millisecond, that means that SQL Server has shipped something to the service tier and just waits for the service tier just to say, yes, I got it. And it takes just forever for the service tier to digest this number of records. So if that is the case, so if you see that this async network I/O is in top ranks and take in half a second or even longer, what you need to do is query tuning. Yeah? What also David presented at the end of his session. And the easiest way to do is to use a script. Also, it's a similar thingy like you have seen before. There are scripts, and again, you can download this from my blog, looking into the SQL Server procedure cache. This is the thingy where we can see all the expensive queries, all queries that have been executed. We can see how often, how long it took, how many reads they had, so that's the memory consumption, the CPU pressure, and there's a column average rows. Yeah, and if you see that async network I/O, top ranks taken forever, then you need to check if you have queries that maybe pump tens of thousands of records and stuff like this. Or if you have queries that are missing indexes, yeah, provoking any stupid index scans and like this. So then we are really back to plain hardcore query tuning. In the worst case, that could mean that you as developers need to split up the results, that you need to apply some programming, not pumping hundreds of thousands of records, but do it in packages of 10,000 or something, which of course is very annoying if you have to do this in the programming. Yeah, but then we are back to query tuning. Unfortunately, this seems to be a specific problem which we have on VMware systems with NAV 2013. There I see this very often. So there also seems to be a problem with VMware, but yeah, our service tier is at least involved, if not guilty. Some of these virtual environments have special requirements regarding the network adapter configuration. Yeah, there's these settings like TCP offloading and stuff like this. Also, there are, for VMware, I know for sure there's configuration guidelines telling you how exactly these adapters need to be set up. Else, also, you will run into this async network I/O problem. Yeah, so that has been the last component I would like to talk about. Yeah, maybe you were wondering where all these fancy diagrams were coming from. They are not created by Windows Performance Monitor. And the last thing I would do today is I want to introduce a very nice tool to you. Also, you find it on Codeplex. that is called performance analysis of log. And it works like this. Oops, I closed it accidentally. So you remember, in the very beginning, I have set up this performance monitoring. That was a selection of counters throughout the system and everything. Okay, so we could schedule, we could start it, and then we could monitor what's going on in the system. And I usually save it into a trace, into these BLG files. And for the investigation, I'm using this PAL. It is a third-party tool you find on Codeplex, but if you see who is the third party, that should ring a bell, yeah? So like David's application profiler, it's Microsoft guys doing something in their spare time. And this PAL you can use. When you have these BLG files, then you can pick up this counter log from wherever you want to do that. And then there are these threshold files. And there's a lot of predefined threshold files for all kinds of Microsoft products and system components. And there's a threshold file for SQL Server. And these threshold files that are XML structures that have inbuilt thresholds, all these best practice values I was telling you, they are built into these threshold files. And now PAL just goes, picks up these threshold files and the trace file. Then there's a little questionnaire and so on. And then it's just next, 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 next. And then some PowerShell magic is running up. And then this monitoring, this BLG file, is analyzed based on these thresholds. And the result of this is a very cool HTML report, whenever it's opening. Which tells you what you have measured. So all the counters are split up, so they are explained. You can see the thresholds that are used for the interpretation. You get these nice graphs, and you get also here the plain figures, so the average values, you see the max and minimum, the extreme values, and everything. And with this, it's very, very easy. You just create this monitoring, just feed it to the PAL. PAL creates a report, and then it really highlights if there's a problem. Never worry about all this yellow and green and red stuff. Yeah? This always refers to threshold violations, but these are exceptions. What is the important part is the average. If the average is white, everything is okay. Yeah, if we have a yellow or red something in the averages, then you have a problem. Yeah, and this report also contains a lot of information about the counters, also links into external sources. There's a section how to speak Zanish, yeah, so that you can learn how to configure Zans and stuff like this. It's a very cool tool. I use it a lot because if there's a problem, it really spits in your face. And it's also a good way to have a documentation. Yeah? If you frequently monitor a system, you can see how it is behaving. Like David said, what we need to do is to see problems coming up before the users are experiencing the problems. And this is a good way to do that. A little small print here is if you have installed the server in your local language and not English, PAL only speaks English. In that case, you need another tool, a tool for the tool, which is called the Pofmon log translator. That can translate the BLG file from local language into English, and then you can feed it to the PAL. Okay. So that was actually everything I'd like to tell about hardware components. And then again, basically, these brief rules, they are easy to memorize, and they are, or they will give a solid fundament for such a server platform. But then again, it always depends on really your individual circumstances. So how the server machine is integrated into your IT environment? Is it a standalone system? Or is it using a SAN you already have? Then you have to ask, who else is using the SAN? If it's a virtual environment, VMware, Hyper-V or something like this, yeah, who else is using this? How is the provisioning? Is it already over-provisioned? All these kind of questions you need to ask, always looking into your local installation. The worst showstopper we have with this hardware sizing is always the budget. Yeah, so as you have seen, it's always a matter of technology versus budget. But by the end of the day, this is problems we can resolve just with money. Yeah, there's not a lot of thinking required or any filling in the code or whatever. It's just take an amount of money and the problem is gone. Yeah, that's the challenges to face. Yeah, do you have questions? Hang on. Oh, sorry, hang on.
I just wanted to ask regarding the TempDB configuration, because if you have a server with 16 CPUs and actually creating 16 TempDBs, I've actually seen that cause contention in its own right.
You have seen more contention than before?
If you have too many TempDBs based on the number of CPUs on your server.
Really?
Yeah.
I haven't seen that. Did you enable this trace flag 1118?
I did, but I went then back to Microsoft and they actually said that you should try and halve it. So start off with less TempDBs rather than 16, for an example, because some servers
so what I mentioned also, I'd rather create no more than 8, in the worst case 12 files. Okay. So I haven't seen that problem, but that's happening. It's weird. It should not happen, but who knows?
No, just ask.
There you go. Okay.
Hi. You mentioned SQL compression. Is that something worth enabling?
Yeah, definitely. Data compression SQL Server, that's one of the coolest features they have invented with SQL Server 2008. And if you are asking, I show you a script. Data compression. So for those never heard about this, this is a way to, on a physical level, to compress data and indexes, having a compression rate of about 80%. So it means if you have a table of 10 gigabytes, data compression folds it down to 2 gigabytes. This has a tremendous benefit for the disk subsystem because you have to store way less of data. And also the growth rate is decreased. This is very, very good option for all kind of supersized databases where in the range of 300 gigabytes and up, because the larger the database, and you need more disks or maybe solid states to handle the database, and sooner or later you can put a price tag on every single table you have to store. If you just calculate the mere money you have to spend for storing tables and stuff like this. And so data compression can really help here. And indeed, our dear NAV has a lot of candidates that are subject for this compression. If you want to do this, you need to have enterprise. So everything that is cool is always expensive. It's all enterprise. There is a script on the Microsoft blog, which is wrong. This is the corrected version. The best practice is if you go for compression, you should only compress data that after the insertion is not modified that much. Yeah, so you insert the data, compress, and then it's done. If you update this data again, it's always uncompress, change, compress again, up and down and up and down, and then it fires back. So you need to know the read-write ratio of this. And this script provided by Microsoft reads out the read-write ratio. And the best practice is read ratio greater than 80%, write ratio less than 20%. And this script here then will pick these candidates. Where you can see this ratio. and then it's also preparing the compression scripts. And if you do this with NAV, the candidates are tables, large tables, let it be more than 1 million records or something like this. All what I call a data graph, that's all kind of ledger entries, that's posted documents and related dimensions in the old days and stuff like this. That's super candidates, but you need to know this read-write ratio. Yeah, so the downside is, or the technical downside is, when data is queried, it is getting uncompressed via the CPU. So if you compress the dirty dozen of candidates we have in NAV, you will see that the CPU load increases about 5, maybe 10%. Yeah, but then again, if you're in this room temperature range, 15 to 25%, then this box can take it. Yeah, so that's really something to go for. Hope this answers your question. Pardon? This one, hang on, who was it? How often you should run this script? First of all, this is reading out the data from the cache. So it is only representative the longer it runs. So when you ever restart the service, all these dynamic management views, which is basis of this, are flushed. All the information is gone. So you need to have the server up running for a long time. That's why I also put the uptime here, yeah, to see if this data is reliable. But once you have picked your candidates and once you have applied the compression, it remains there. If the table has a clustered index, then you only need to tell it once to compress, and all data that is added is automatically compressed. If you have heap tables, so that's tables without clustered index, then you need to rerun the compression. But Navision makes sure that all the tables have clustered indexes, and so compression works. So,
I have two questions.
I have a souvenir for you on top here.
First, in the Sun system, have you ever need
Sorry, I don't hear you.
in the Sun system, have you ever monitored the batch? In the Sun system, have you ever need to watch the buffer memory?
In what system?
In the Sun system, because
The SAN, the buffer cache hit ratio.
Yes, have you ever need this? Have you ever monitor the buffer?
The SQL Server buffer cache hit ratio.
No, in the Sun, the SQL delivers to the Sun the writes statement.
The SAN cache.
The Sun cache. Have you ever
Yeah.
have you ever feel the need to monitor the Sun memory?
Yeah. So yes, because as shown that the most important part of the SAN is the cache, but I cannot tell how to monitor this because I don't know, as far as I know, there is no Windows performance monitor from this. You need some ZAN magic to do this. I know, for example, from the NetApp guys, they have command line tools and everything. They really can look into every single spindle and see how it's turning, how much load is there, how much the cache is hit so far and so on. So I cannot tell how to monitor this. I know that there are monitoring tools, but obviously this varies from ZAN to SAN technology.
Yes.
So
this is my problem, is because there are several SANs, and I can only monitor from the Windows perspective.
no, from a Windows perspective, all I can do is with a stopwatch and see how long it takes. But what it internally is doing, I think that's something we cannot find out.
Okay, the second question is, do you change the files in the TempDB by changing the model or by adding some startup script?
No, I changed this script, these TempDB files manually. So, yeah, because that's a one-timer. You do this when you install the SQL server. It's not a periodic job or something you have to do. Oh, thank you very much.
Okay, is there any thinking or any best practice to use in-memory technology together with NAV or
What kind of memory?
In-memory technology. With this SQL Server 2014, there comes this in-memory feature, which is quite cool, but not for maybe environments like NAV, but maybe there are thinking.
Yeah, in-memory processing. So, okay, this is a very cool thing, but the problem is this. There's multiple ways to do this kind. First, there's technological way of firing up data into memory. The next level beyond the Fusion I/O cards is, for example, phase change memory cards. That is flash combined with non-volatile RAM. So it means when power is on, all the data is fired up into memory. So that's real memory disks that store the data. Such a price tag, yeah, no way. But the I/O is tremendous. The next level is SQL Server 2014, optimized for memory, these tables. I only have seen benchmarks, but non-NAV benchmarks, and the performance gain is dramatic. Today, I only have 2 customers which are running on SQL Server 2014, and they are in a development phase, and yet I don't dare to fiddle with this feature because I don't want to spoil the Navision development. I have no idea what would be the impact. But we have an agreement, once they have a stable state in the progress of testing, then we will pick some candidates. I can imagine that tables that have a heavy I/O, like item ledger entry or something like this, that could benefit from this. But the risk is, I don't know what is the challenge for the RAM. Yeah? How much memory will be used for these tables, and what other impact will happen. Yeah, so this is all the challenges that I think we only will be able to face when it's done. It's hard to predict, yeah, because it's difficult to create these test scenarios. Again, these 2 customers are willing to test, and then we will find out. So unfortunately, that's the only way to get best practices, to do it in the practice. Did I give you a shirt? Yeah. Okay, I have no shirt, I have 1 book.
You mentioned the Fusion I/O device, and prices are going down, but I wouldn't use it anyway for a database because it has no redundancy and it's not hot pluggable. But one idea was, would it make sense to use this for the TempDB?
For the Fusion I/Os?
For the Fusion I/O, or NVM Express, what's coming up in some way?
Technically, yes, of course, because for the TempDB, who cares if it gets corrupt? Because it's recreated whenever you start the service. But the question is, you want to spend this amount of money for the TempDB. Okay, your prices are decreasing.
Soon it's not too much anymore. And if you mentioned the licensing for enterprise, and so it's all peanuts.
Yeah, no, definitely. So that for sure is an option. I also have seen benchmarks where some cowboy guys were just taking some freeware third-party RAM disk tools, just RAM disk tools, creating a RAM disk, putting TempDB on it.
Also, it's always redundancy first, of course, and I would never put a database on a Fusion I/O card because it's not redundant. But if the if it crashes and the TempDB,
I'm not sure
you have to move it.
You can do some kind of mirroring with a Fusion I/O. I don't know how they handle this.
That would be my second question, if I may.
No, I don't know. I don't know. So technically, because it's just a solid state, it's just a different bus. So I guess it depends on how many PCIe slots you have.
Sure.
So and how this could be configured.
No, if you can afford it and if you can plug it in, but only use it for the TempDB because you wouldn't lose anything. You must have a strategy to move the TempDB if the card crashes.
Yeah, no, that really makes sense because if there's any corruption, if the power goes down or so, you don't lose any information. Yeah, is Mark Brummel here? Because I think he just recently installed a Fusion I/O on a database, so he could tell.
This will now be my second one.
Okay, then you can sell it in eBay. Okay. Okay.
Do we have one last question, or we're over time?
So one last, very last one, and then I'm out of souvenirs. So, and only questions I can answer. Yeah.
Sorry. When you were talking about the parallelism, how do you know how many threads you have in the CPU?
Pardon?
When you do the parallelism, how do you know how many threads there are?
How many threads SQL Server creates? I cannot demonstrate. Okay, but first of all, you see it in the execution plan if parallelism happens. I don't know if you ever checked these execution plans. Something like this here, whenever it fires up. And if you have kind of a yellow circle with two black arrows, then you have this kind of parallelism. I think it is also shown, you can see in the profiler how many threads have been created. Or in the easiest case, if you find such a query on the fly, and if you just run a simple sp-who, then you could see how many threads have been created for a single process. Yeah, so for example, if you run index maintenance on integrity check, which takes a little longer, then you can see it. Or if you run a backup, that one SPIT, yeah, you will have one SPIT with multiple times, and you see all these threads in the different states. Okay, yeah, so over time. So thank you very, very much for your attention. And now let's grab some food.